Hello everyone. In this video, we're going to go over question 1, which is referenced against 8.3.6t from the 8-3 homework. So let's get a new one. So let me generate a similar question. Here we are. Use technology to find the p-value for a hypothesis test described below. The claim is that for 12 a.m. body temperatures, the mean is less than 98.6 degrees Fahrenheit. The sample size is 7, so that means the degree of freedom is 1 less than that, it's 6. And we're giving a test statistic already of t equal to negative 1.538. So just as a summary of how we learned this in class, we could also get this directly from the table. Realizing that this is a one-tailed test, just the left side, we can go and look at the area in one tail. The degree of freedom is 1 less than the sample size. So what we want to go ahead and look at is this row 6. And yes, it is negative, but this curve is symmetric. So what we can do is just ignore the negative and realize it will have the same area. All right, so we had, let's check it, negative 1.538. So if we were to look at the table, that would fall right in here. So negative 1.5, and area in one tail means that the p-value should be between 0.05 and 0.10. So if we were needing to use the table, we would just say something like 0.05 is less than the p-value, and that is going to be less than the 0.10. But we are asked to use technology to find the exact value. To do that, we can go to StatCrunch, and inside StatCrunch, well, really zoomed in, let's look at the whole space. We can go to, let's zoom that out a little bit. So you can go to Stat, Calculators, and down to T, and then you get essentially some prompts that you need to fill out. Another thing you can do is just Google StatCrunch T calculator. It'll be the first result. And I'm going to use this one because it's a little bit bigger. All right. So how do we work with this? Well, the degree of freedom will affect the distribution. So we are given a degree of freedom of 6. So let's change that to 6. And then this line, we have X as a placeholder for T. So again, depending on the context, your test statistic may be a Z, a T, a chi-squared. So here's a t-score. So this is where our test statistic is going to go. And so that is going, let's go ahead and grab, can I copy that? Unfortunately not. So negative 1.538. So negative 1.538. And it is a left-tailed test. If it was a right-tailed, you would have to change that to greater than. And leave this blank because when you hit compute, it'll actually go ahead and tell you the area in this part of the curve. So this is going to be 0.0874. We need to round this to 3 decimal places, so round that down naturally to 0.087. And again, notice that that is between 0.05 and 0.10. It's between 5 and 10%. That's about 8%, almost 9. So going back here, pasting that in, checking our answer, we get a compliment, nice work. So hopefully that helps, and good luck.